All right, welcome back to example 3, one at day 23. So we have the function s is equal to the sum of mxi plus b minus yi squared, and we're going to derive the least squares linear formula for this, okay? All right, so to begin, we're going to start with the partial of f's with respect to m, which gives us 2 times the sum of mxi plus b minus yi times xi, which is equal to 0. And then we're going to take the second partial and take the derivative with respect to b, and that's going to give us something sort of similar. So I get 2xi plus b minus yi, and that's equal to 0. Okay, so if we look at this one, if I look at this one, it's going to give me distributing the equal, or the linearity of the sum here, ds dm is equal to, since the 2 is being multiplied everything and this is equal to 0, I can actually divide by it, so you're not going to see that 2 being affecting anything. And I get the sum of m xi squared, distributing the xi through, plus the sum of bxi minus the sum of yixi, and that's equal to 0. Okay, and then looking at this one, okay, we're going to get we have the sum of m xi plus the sum of b minus the sum of yi, that's equal to 0. Okay, so with respect to the sum, the m is a constant and the b is a constant. So if I look at these, pulling out the constant pieces, you can see that I'm going to rewrite this entire thing together, and so I have that this first one is going to be m sum of the xi squared plus b the sum of the xi minus the sum of the xi yi, and I can assume that they're associative since they are real numbers. And also here we have m the sum of xi plus b times the sum of 1 minus the sum of yi. And if that's equal to 0, then I can say that that's equal by just moving those over. Since these are both equal to 0, I can move these sums over, just like I did there. Okay, and so now we want to use this information to solve for our parameters, which are the m and b. Okay, to do this, we'll use Cramer's rule. Okay, so we have then, again, we're looking for the m and b's here, and so we're going to solve those parameters using the Cramer's rule. Okay, so to do that, we have, okay, let's see, we got d is equal to the sum of xi squared, and this is the xi, and then this is the xi, and this is n. That's coming from here. Okay, and that is equal to n times the sum of xi squared minus the sum of x I quantity squared. Okay, so that's just the determinant, right? So this is this minus this times this, which is that. Okay, all right. So then using Cramer's rule for the m term, we have the sum of xi, yi, sum of yi, sum of xi, and n. And so this gives me n, the sum of xi, yi, minus sum individually of sum of x and yi. Okay, and then for b, so this is the result for Cramer's for m, and now for db, let's see what we got there. We have the sum of xi squared, sum of xi, sum of xi, and n. So sorry, sum of yi. There we go. Okay, so xi squared, xi, yi, xi's, and the xi's. Yeah. So if we look at the determinant of this one, we get the sum of xi squared, sum of yi, minus the sum of xi, sum of xi, yi. Okay. So finally, computing the determinants, there they are. And so finally we have that m, the parameter m that we've been looking for, is going to be d m over d, which we saw was in xi, yi, minus the sum of xi, sum of yi, over in sum of xi squared minus the sum of xi whole thing squared. Okay, check. Okay, and then finally the parameter b, this is db over d, and so we get here that this is the sum of xi squared yi minus the sum of xi, sum of xi, yi, all divided by in sum xi squared minus the sum of xi quantity squared. Okay, all right, so that checks out. And so finally, then, now that we have this derivation, okay, then to show or to prove that y bar equals b plus mx bar, okay, we have y bar is equal to the sum of xi squared, sum of y, this is yi, times the sum of xi, sum of xy, I, divided by n sum of xi squared minus sum of xi quantity squared plus sum of xi over n over n sum of xi yi minus sum of xi sum of yi over sum of xi squared minus sum of xi squared. All right. Combining like terms, it looks like we have the sum of xi squared, sum of yi, minus the sum of x, sum of xyi's, plus the sum of x, sum of xi, yi. So I see some good things starting to happen here. 1 over n, the sum of xi squared, the sum of y I all over the sum of xi squared times n minus the sum of xi squared. Okay, so those two simplify out, and then we are left with the sum of y, factoring that term out as a product. What are we left with? We're left with the sum of xi squared minus 1 over n times the sum of xi squared divided by n, and if I factor out an n from both of these, I'd have a 1 over n here, so it's going to be the sum of xi squared minus 1 over n, the sum of xi squared. And so finally those reduce, and you're left with the sum of yi over n. All right. I hope that was helpful, and I'll see you in the next video.